Hey everyone, welcome back, and let's write some more Leetcode today. So today let's solve the problem remove element. We're given an integer array of nums and a particular value, a second parameter value, and we want to remove all occurrences of this value that we're given as the second parameter. We want to remove all occurrences of it from the other parameter, the nums array, and the trick here is that we want to do it in place, meaning we want to do it without allocating another array. We want to do it just with the input array that we're given. So basically, if you read the next paragraph, since we want to do it in place, the main way that they want us to actually implement this is by taking all the values in the input array nums that are not the particular value. And then place all of those at the beginning of nums. So suppose we had k values in the array nums that are not the value, the special value that we want to remove, then we would return k saying that, okay, there's k values in nums that are not that special value, and all of those k values have been placed at the beginning of the array in place. That might seem kind of complicated, so it's best understood with an example. So take a look at this input array that they are giving us, and the special value that we want to remove is value 2. So we want to remove all occurrences of 2 from this array. Now, by remove, they don't just mean delete the value, they mean do it in place. So in the output, you can see this is what we want the array to look like. So you can see that all the values that are not 2 have been placed at the beginning of the array. The relative order, as you can see, does not actually matter, right? Like 4, 0, 3 is not the order that they appeared in the input array. In the input array, they were given as 3, 0, 4. So it doesn't matter what order we do it, but we have to put all the values that are not 2 at the beginning of the array. But this array, this output array, is not what we're actually returning. We're just returning 5, indicating that there's 5 values in the array that are not 2. And like I said, the trick to doing this is doing it in place without allocating any extra memory, as you can see up above. So returning the value itself, 5, would be easy in this case, right? It's easy to count which values are not 2. But doing the actual in-place modification is tricky if you're a beginner, so let me explain it. So how would we want to do this? Of course, we can see the first 2 values. These are not 2, so we don't have to do anything with them, right? Okay, the next values are 2, but we can't just delete them, right? We have to replace them with other values that come after them, right? Basically collapsing these values onto the 2s that we want to remove. So we read the 2s, then let's say we get to a 3, right? Where do we want to put this 3, right? We don't know that there's anything else in the array. There could be, there might not be. Where would we want to put this 3? We could put it in this spot, replacing this 2, but it would be much better to put it over here, right? Replacing this 2, because we want to put all of the values that are not 2 at the beginning of the array. So it's better to put it here. So suppose we do that. We replace this with a 3, and the real 3 can just stay here for all we care. And then next, we're going to get to a 0. So this is also not a 2. And we'd want to put this over here, right? We know there's another 2 over here. So let's put the 0 over here, right? So basically what we're learning by just going through this example is it might be very helpful for us to keep a pointer, let's call it K, or let's call it I, or whatever you want to call it. A special pointer basically telling us next time we find a non-2 value like 3, 0, 4, where should we put it, right? We should put it replacing the 2, wherever the first 2 happens to be. And then once we do that replacement, right, we'll take our I pointer and then shift it by 1, saying, okay, next time we see a non-zero value, like 0 in this case, then put it over here. And then again, we'd take our I and then shift it. But this time, see, our I pointer is at a 3 value. But it's okay for us to, next time we get a 4, to put the 4 over here, replacing the 3. That's perfectly fine, because remember, we already took this 3 and then put it over here. We already shifted it by once. Okay, so that seems pretty simple, what we need to do when we see a non-2 character, but what happens when we do see a 2 character, right? Let's say our I pointer is over here, and then we arrive at this 2. Would we want to put the 2 over here? No, because we only want to put non-2 characters at the beginning of the array, right? We don't care about the actual 2 character. And I've been using I for this, but it's probably better to use K. This K value will actually be the output value that we end up returning in this problem, because this K is going to be incremented every time we see a non-2 value. So it'll tell us by the time we've reached the end of the array, it'll tell us how many values are in the array that are not 2. So that definitely makes sense for us. Now, one thing you might be wondering is, we initialized our K pointer over here, but isn't the K pointer initially going to be at the beginning of the array? And, suppose we didn't even have any 2s at all. What are we going to do in this case, right? We're going to say, okay, we have a 0. This is not a 2. So does that mean 0 is going to be swapped with itself? That doesn't really make sense. And then would we want to still shift our K by 1 because we didn't see a 2 in this position? And you're right. It doesn't really make a lot of sense to do it, but it elegantly does work out with the code, right? For example, if we did not have any 2 characters, right? Suppose these didn't exist and this didn't exist. How would the algorithm that I'm explaining, how would it actually run? Well, we'd see a K, we'd start with a K here. We'd say, okay, this is not a 2, swap it with itself. Okay, then K gets incremented by 1. This is not a 2, swap it with itself. Okay, K gets incremented by 1 to over here. Swap it with itself, swap this with itself, swap this with itself, and then we're done. And then by the end of it, our K pointer would be over here. It would be at position 5. And we would want to return 5 because that's the number of non-2 values in the array. And then this is what our array would look like. We didn't actually modify the array at all if this was the input array itself. So you can see that this algorithm, it's simple, but it does work in all the edge cases that we need it to work in. So it makes sense, and without further ado, we can now jump into the code. Okay, so now writing the code, remember the main thing that we're just going to be maintaining in this problem is just the K pointer. Initially, it's going to be at index 0, and then we are going to just be iterating through every single value in the input array. We're going to be doing that with a pointer I, so let's just get the length of the input array nums, and then do that. Remember, if we see a 2 value, then we're just going to ignore it, right? We're not going to execute anything. But if we see a value that's not 2, or I keep saying 2, but we actually want the second parameter that was given to us called val. So if this is not equal to that special value, that's when we're going to be performing the swap. If we do see that special value, then we can just ignore it, right? We don't want to take that special value and then push it to the beginning of nums. We don't want to do that. And basically from what I'm writing, you might actually recognize that this algorithm that we're doing is kind of similar to the partition of like a quick sort or quick select. By partition, in this case, we're taking all values in nums that are not this particular value and then putting them at the beginning of nums. That's what we're doing when we say partition, if that makes it easier to understand for you. But like I said, so if it's not the special value, then we can take this and then put it at our index K, which tells us where to put the next value. So we'll put nums of I at position K, and then we will increment our pointer by 1. This should be an I, not a K. So then we'd increment by 1. And then if it is that special value, then we won't do anything. We'll just skip it. And then once we're done with this, remember what we actually want to return is K itself. We don't want to return nums. We want to return K. So that's the entire code. Let's run it to make sure that it works. And as you can see on the left, it does work and it's pretty efficient. It says 12%, but I'm pretty sure this is as efficient as you can get for this problem. Feel free to correct me if I'm wrong, but I hope that this was helpful. If it was, please like and subscribe. It supports the channel a lot. Consider checking out my Patreon where you can further support the channel, and hopefully I'll see you pretty soon. Thanks for watching.